everybody another SMO. This is Singapore Mathematical Olympiad 2009, problem 27. It may be from different section or something. I know there's a bunch of different sections, but anyway, it is the year 2009. It was labeled problem 27. Now, here's the problem statement right here. It says let x1, x of 2, x of 3, x of 4 be the four roots of this polynomial. And you're supposed to actually determine the value of k here. K is a constant, it's the coefficient of x squared. Now, this is something called Vieta's formula, but I don't like memorizing stuff. And so I've written out an expansion here where x1, x2, x3, x4 are all explicitly the roots. Now, I didn't write equals to 0, but a tremendous amount of work here, and I didn't show all the results, but what happens is you get the sum of the zeros minus the sum of the zeros as the coefficient of x cubed. All right, then you get this crazy combination. This is actually 4 choose 2 ways to pick the variables. 1, 2, 3, 4, 5, 6. Now notice the signs here. The signs stick around because you're literally picking 4 variables with a minus sign in front of each of them, right? Now the sign of the variables themselves is not important. It's just that there's a minus sign in front of all 4. Now right here, notice you have a plus sign. That's because these minus signs cancel out pairwise. You know, a negative times a negative is of course a positive. So you have a negative times a negative, negative, but they cancel out pairwise. So that's why you have a plus sign here. So again, you have the zeros of this polynomial expressible as the coefficients of these terms here. So it's kind of interesting. And that's really what this whole problem is based on. Again, this is called Vieta's. Now here in a similar fashion, you have a minus sign because you're picking 3 minus variables at a time, all right? And finally, they all cancel out here. The product of the zeros is clearly these terms right here. So anyway, notice that in this particular problem, let me get my pencil working here. You actually have a 0 x cubed term right here. Okay, I'll put 0 x cubed. Okay, y'all, that's supposed to read 0 x cubed. So there is a missing 0 term or third degree term. And so for that reason, we actually have to set the x1, x2, x3, which is the coefficient of x cubed here, we have to set that equal to 0. So we do know that the sum of the zeros is equal to 0, actually. All right, now k, which is what we're looking for, is this next part of this expansion that we just talked about, you know, where there's 6 terms in it. So k is equal to these 6 terms. And it seems like this would be an impossible problem at this point in time. Like, how do you do this? But notice that we are given that x sub 1 times x sub 2 is 49. Now this really isn't sequential, folks. This was really my first step right down here. Notice that minus 2009, just from the statement right up here, minus 2009 has to be equated to the product of the zeros. Okay, we're already given, we're given that x sub 1 times x sub 2 is 49. So you see how 49 just replaces x sub 1, x sub 2 right here? But that tells us that x sub 3 times x sub 4 is negative 41, right? Okay, now that turns out to be extremely useful right up here. Notice that you can factor an x sub 1, x sub 2 out of these first 2 terms. All right, you can factor x sub 1, x sub 2 out of these first 2 terms, and that's the 49 that's given. But then what do you have? You have x sub 3, x sub 4 left over, right? And in a similar fashion, the minus 41 that we just got will be right here. Okay, and that's x sub 1 plus x sub 2. But you see, for this to hold, for this to be equal to negative 90, x sub 3 plus x sub 4 has to be negative 1, right? So this would be a minus 49 minus 41 is minus 90 if we force x sub 1 plus x sub 2 equals to 1. So you see, that's very useful right there. They're additive inverses of each other. And so from right up here, you see we're good to go because this would be 49 as given information, right? That's 40. This piece right here is 49. It's given, right? And we just concluded down here based on Vieta's result, basically, that this would be minus 41, right? So all of a sudden, 49 minus 41 is 8, right? Now notice something very cool happens here also. X sub 1 is common to these two terms, so you get this statement right here. And then the same thing with X sub 2. All right, and so when you do the appropriate factoring, you end up with this. You'll see that it's kind of cool. X sub 3 plus X sub 4 is common. It's a common binomial factor. But we know that X sub 3 plus X sub 4 is -1. All right, and then this is 1. So you get 8 minus 1, and voila, there's your answer. Well, that's pretty cool. It's a nice problem. It's a nice problem. And I hope all of this helped right up here. It helps me. I don't like to memorize those Vieta's formulas. But if you multiply this out, you can see why these signs, you have these alternating signs as you move across. Like there's another minus sign right there, right? So they kind of alternate minus, plus, minus, plus, minus, you know? And you have to take that into account when you're writing all this down. And y'all, again, I apologize. I didn't really write this. But what I really wrote down first was just this and this, right? All right. And then I wrote down just this. This was just the beginning. I'm just trying to keep it all on one screen, so it's a little confusing. And then I wrote down just this much right here. And the rest of it is just work I attached rather than going to another screen. And so apologize for that confusion. But it just keeps it all on one screen. And again, I think this is extremely useful right up here. Let me know what you think.